Use a polynomial regression calculator to answer questions about the given data. All right, so we're going to use some technology here. Let's go to my website, goldadder.com, and let's click on the math links. We've done a quadratic regression before, but this time we don't know if it's quadratic. We don't know if it's linear, quadratic, or it could be cubic. So we're going to click on polynomial regression. We're going to do a polynomial regression because we don't know what degree it is. Now, this website's a little bit tricky at first to use, but let's see how to enter the numbers in. Okay, so what we want to do is we want to enter in these XY points into this website. But the trick is you have to enter them with no commas. So the first point is -3, 391. Hit enter to go to a new line. -1, space 25, no comma, 0 space 4, 2 space 16, 5 space 799. Okay, so we're going to calculate this thing, and it says select polynomial degree. So this is trying to see if it's a quadratic, degree 2. Okay, so you see it gives us an equation, perhaps, but what we need to pay attention to is this r squared value. All right, this r squared value is important, this 0.9921. Let's round off to 4 decimal points. Okay, so the r squared value for degree 2 was let's go red, 0.9921. 0.9921. That number tells us how good of an estimate our equation is. So that equation up there, y equals 39.07, blah, 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 may or may not be a very good estimate. It depends on that r squared value. So let's change it to a degree 3. Okay, hit calculate. And you see the r squared value has changed. The equation has changed to an x cubed, because it's degree 3 now. But notice it says 9.95, and then at the end here it says times 10 to the negative first. Okay, remember when we talk about scientific notation, that's going to take the decimal and move it one place. So really that's not 9.95, it's going to be 0.99. So 4 decimals is going to be 0.9959. So for a degree 3, 0.9959. Now here's what I'll tell you about the r squared value. Find the r squared value. The closer the r squared value is to 1, the better this regression is. All right, so we can tell that a degree 3 is better than a degree 2 because 0.9959 is closer to 1. So let's try a degree 4. Calculate. Aha, this one looks nice. Notice the r squared value is exactly 1. That's perfect. That's what we want. Okay. The closer the r squared value is to 1, the better the estimate is. All right. So part B to this says which is the best model for the data. It's a degree 4, which is quartic. All right. Linear is degree 1, quadratic is degree 2, and cubic is degree 3. But we're a degree 4, quartic. And if you go back to the site, look at your result, your equation, y equals 2x to the 4th minus 5x to the 3rd plus 8x squared. That's our equation, that's our model. So we're going to copy that down. For the next question, give a model that best fits the data. Y equals 2x to the 4th minus 5x to the 3rd plus 8x squared minus 6x plus 4. That is a model or an equation that best fits the data or these points given above.